Having mastered the relationship between exponents and radicals, we may now proceed to the laws of radicals. The first law is the nth root of a raised to n is equal to a, which means that the root of a number raised to that same number is equal to the number. Or in other words, if the index and the exponent are equal, the simplified form of that radical expression is equal to the base. For example, cube root of 4 cube. As we may observe, the index and the exponent are both 3. Therefore, using the first law of radical, we may simplify this radical expression to 4. Second, the square root of 64. Square root of 64 can be written as the square root of 8 squared, because 8 squared is equal to 64. And now that the exponent and the index are both equal to 2, we may now simplify this to 8 using the first law of radical. Third, fourth root of 16. 16 may be written as 2 raised to 4, since 2 raised to 4 or 2 times 2 times 2 times 2 is equal to 16. And now that we have written, or we have shown that the exponent and the index are both 4 or have equal values, we may simplify this radical expression to 2. The second law of radical is the nth root of a times b is equal to the nth root of a times the nth root of b, which concerns about the radicands that can be factored and simplified to the given index. For example, the square root of 50. 50 can be factored out to 25 times 2. And we may rewrite this radical expression as the square root of 25 times the square root of 2, applying the second law of radical. Now, to simplify this, we know that the square root of 25 is equal to the square root of 5 squared, because 5 squared, or 5 times 5, is equal to 25 times square root of 2. Simplifying this further, we may now cancel this out, so 5 will remain, and square root of 2. So the final answer for this one is 5 square root of 2. Second, cube root of x raised to 5. X raised to 5 can be factored out to x cubed times x squared, because x cubed times x squared is equal to x raised to 5. Applying the laws of radicals, we may write this as the cube root of x cubed times the cube root of x squared. Using the first law of radical, we may cancel this out, so x will remain, and cube root of x squared. Last, the fourth root of 32a raised to 7. 32 can be factored by 16 and 2. So we may rewrite this as the fourth root of 16 times 2, because 16 times 2 is 32, while a raised to 7 can be factored out to a raised to 4 times a raised to 3, because a raised to 4 times a raised to 3 is equal to a raised to 7. Now, we may simplify this as the fourth root of 16 times the fourth root of 2 times the fourth root of a raised to 4 times the fourth root of a raised to 3. And we know that fourth root of 16 is equal to the fourth root of 2 raised to 4, because 2 raised to 4, or 2 times 2 times 2 times 2 is equal to 16, times the fourth root of 2 times the fourth root of a raised to 4. Applying the first law of radicals, we may cancel this out, so this would be equal to a times the fourth root of a cube. And now we may cancel this out also, so 2 will remain. Then let us write a now to arrange the terms, and then these two terms will remain inside the radical. So this will be fourth root of 2 and fourth root of a cube. The third law states that the nth root of a over b is equal to the nth root of a divided by the nth root of b, where b is greater than 0, which is concerned about the roots of fractions provided that the denominator of the radicand is greater than 0. Let us have some examples. First, square root of x squared over 9. So the first thing that we have to do is to distribute the index of the radical to both the numerator and denominator. Doing so, this radical expression would be equal to the square root of x squared over the square root of 9. Simplifying further, using the first law of radical, the square root of x squared would be equal to x. And square root of 9 may be written as the square root of 3 squared, because 3 squared or 3 times 3 is equal to 9. Simplifying this further, square root of 3 squared is equal to 3. Therefore, the square root of x squared over 9 is equal to x over 3. Second example, the cube root of 64 over x raised to 6. Using this third law of radical, we may rewrite this as the cube root of 64 over the cube root of x raised to 6. 64 is equal to 4 cube, or 4 times 4 times 4, and that is 64, divided by the denominator, which has a radicand x raised to 6, is equal to x squared cube. Because x squared cube, applying the laws of exponents, is equal to x raised to 6. We will now simplify this further as the numerator 4 and the denominator x squared. So we can say that the cube root of 64 over x raised to 6 is equal to 4 over x squared. The fourth and the last law is the mth root of the nth root of a is equal to the mnth root of a, which is further equal to the nth root of the mth root of a, which states that the root of a number is equal to the root of the number when the two indices are multiplied, and is further equal to the root of the number when the two indices are interchanged. To make it clearer, let us have some example. Sixth root of 4. Now we will use this property to solve for this given radical expression. Sixth root of 4, using the fourth law of radical, can be written as the cube root of the square root of 4. The index here is 2, and 3 times 2 is equal to 6. So we may write this as the cube root of the square root of 4. And 4 may be written as 2 squared. So it will be easier for us to simplify this expression. And 2 squared, its square root is equal to 2. So we can simplify this as the cube root of 2. And this would be our final answer. The sixth root of 4 is equal to the cube root of 2. Second example, cube root of the square root of 27. Now in this example, we will use this second equality. We may interchange the indices in a given radical expression. So here, the index of 27 is 2 and 3. We may interchange this and write it as the square root of the cube root of 27. And 27 may be written as 3 squared because 3 squared or 3 times 3 times 3 is equal to 27. Now using the first law of radical, we may now cancel this out and then 3 will remain. So the cube root of the square root of 27 is equal to the square root of 3. Applying the laws of radicals in simplifying radical expressions requires you to also understand when a radical is already in its simplest form. And a radical is in its simplest form if the radicand does not contain a perfect square, cube, or nth power. For example, square root of 2. Square root of 2 is in its simplest form since 2 is not a perfect square, meaning the square root of 2 is not exact. Next example, third cube root of 5. Cube root of 5 is in its simplest form since 5 is not a perfect cube, meaning the cube root of 5 is not exact. Second, a radical is in its simplest form if there is no fraction in the radicand or no radical in the denominator. The expression square root of 3/4 is not in its simplest form because there is a fraction inside the radicand. We can apply the third law of radicals and rewrite it to square root of 3 over the square root of 4. The denominator square root of 4 can be simplified to 2, so the simplest form of the given radical expression is square root of 3 over 2. Third, a radical is in its simplest form if the index of the radical is the lowest possible index. The sixth root of 8 is not yet in its simplest form since the index 6 can be expressed as the product of 3 and 2. To simplify, use the fourth law of radicals, then express it as the square root of the cube root of 8, and that is equal to the square root of 2 since the cube root of 8 is 2 and square root of 2 is not exact. And always remember that you have to simplify radical expressions with a perfect nth factor, a fraction in the radicand, a radical in the denominator, and a reducible index.